So what I want to talk today is I'm going to talk about two things. I'm going to talk about JavaScript, some interesting aspects of JavaScript that make it interesting to analyze from the point of view of looking for elements that are functional and looking for elements that are imperative, and how the JavaScript kind of wraps it all up and mixes it up a lot. And the other thing that I want to also talk about is frameworks, object-oriented frameworks that really were some of the most valuable of objects in general, were the frameworks that were then people were able to code up and so that others could reuse. So let me get started on JavaScript. And JavaScript is a gigantic language. There's lots of it. But I just want to focus on three things. I'm going to talk about objects and functions. I'm going to talk about something in JavaScript called the prototype. For those of you who have coded in JavaScript, maybe you have seen this. In any case, whether you've dealt with JavaScript or not, it's an interesting little piece of design that is worth knowing about. And then I will talk about how to emulate inheritance in JavaScript, because JavaScript does not have inheritance. So it has just object prototypes, so just like the exercise that you're doing. I think it's the exercise number 13. That's basically the model of JavaScript. So here's the thing about JavaScript that is kind of a little riddle. There are no classes, so you have objects, but there are no classes. You define objects by literally, or there's different ways of creating objects, but there are no classes. Interesting thing, objects are dictionaries, basically maps, just like the exercise that you're doing on chapter 13. But the other interesting thing is that functions themselves, what you think of as functions, when you declare a function with the keyword fun or something like that, a function, keyword function, they're actually objects too. And so they have properties and methods and other fields that you can access, even though they look like functions. And they are functions, but they are defined as objects. So it's a big interesting kind of loop in the JavaScript world. So let me talk about objects. So how do you create objects since there are no classes? You can create it in two ways, with what's called literals, object literals, or you can create it with functions, which, as I said, are objects. So here we go. So here's an example of an object literal, which I already covered on Tuesday. So here's an object apple, looks like a dictionary, right? It's a map. So it's a key value. It's a little data structure of key value pairs, and the keys have names, so type, color, and get info. And the values are, some of them are primitive values like strings, and others can be lambdas, functions, anonymous functions, right? So here's one value that is just a function. So, and with this, you have an object, you have created an object. Apple is, by all accounts, an object, a JavaScript object. And then you can evoke the fields and the methods in the regular way that you evoke fields and methods in object-oriented programming with a dot notation. So apple.color, apple.getInfo, and given that it's a function, you call it. All right. So this is how you create an object via a literal in JavaScript. You just declare it. Here's another way of creating an object via function. So here's a function, and this is many variations I'll walk you through. So here's a function, an apple, capital Apple, that takes a parameter, some type of the apple, I guess. And then there's this mysterious this that I will talk a little bit more. But so there's some notion of fields in here, type, color, and get info. And some of them are values, the regular values. Others are, for example, this one, get apple info, which is an externally declared function. Right? So this is still a function, except that it's externally declared with a name. It's actually not a good pattern, so it's not, you're not supposed to do this. But it it gets the job done. So then how do you create, once you have this function capital Apple, okay, which is still not, well, it's an object, but it's a special object, a function object. So how do you create an actual instance of this function object? You create it with a new, okay? This starts to look like the regular object-oriented programming languages. So new Apple, even though Apple is just a function, it's not a class, all right? And then from here on, Apple is an object. Okay, so now we have functions that kind of look like classes, but they really aren't, and that we'll get to see a little bit more of what is going on in here. So functions are, remember, keep in mind, functions are objects. So here's a little better that you just put the function directly inside here, right? So you get the function over here, same thing. Don't define externally. Right, so this is the same thing. So the function this is an anonymous function, you don't need to give it a name, and that's the body of the method. So you have, and in this case, look what is going on in here. So in this case, you're creating a Apple instance by instantiating, by using the keyword new on a function, an anonymous function. You didn't even define a named function. So this is an anonymous function, right? And you're creating an instance of this function, sort of a copy of this function, right? In the form of the Apple object. So many ways of creating objects, and they're all objects in JavaScript. So the first thing is the keyword this. So even in this way of defining things in JavaScript, having an external function that will then be bound to be a method of this object, you can refer to the keyword this, which is a weird thing, okay? But so what is this? It's unbound at this point, but again, JavaScript is interpreted. It's an interpreted language. So hopefully when things run, this will be bound to something, right? And it will be indeed, when you invoke the method like this, apple.getInfo, mysteriously, the this inside the getInfo will be bound to Apple, to the object Apple. Okay? This is a piece of magic that we normally don't see, we as programmers, but it's done by the virtual machine, the Java virtual machine. And actually, it's part of the spec of JavaScript, that the target of the invocation is the one that is going to be bound to the keyword this, okay? So how is that done? This is done through what's called function contexts, okay, in JavaScript. Basically, a function, which I said is an object, there are two methods defined in function objects. There's the method, they're almost the same. There's the method call and the method apply, and they're almost the same. Just that the parameters are just slightly different. But basically, the important thing is that there is just like in Python. Remember when I explained to you the self in Python, that when you declare a method, you declare it always with the first argument self, right? And when you call it, you don't actually explicitly send an object, but it's implicitly in the way that Python is implemented. So it's the same thing here. Except that in here, you actually don't declare it. Even in the declaration, you don't declare the self. So it's magic, it's hidden. It's hidden, but it's there. But basically, the functions all have these two methods. And these two methods, which are going to call functions, right? This is the methods that get invoked by the virtual machine when you call functions. There is a first object, a first argument to these functions that's supposed to be the target, right? So this is the target object, okay? And this is the one, so it's called a function. The function context. And so this can be this is an object, this is literally an object, and you can put arbitrary things inside. And in particular, you can have arbitrary things like, whatever, things that you will be referring to in the body of the function that at the moment of the body of the function are not defined, but when the function actually runs, they will be found, they will be looked up in the context which is this first argument, okay? So the context is an object, meaning in JavaScript, it's a key value pair, right? And if the body of the function refers to any name that is not a local variable, the first place where it's going to be looked up is in this context argument that it gets, okay? So it's sort of really malleable. So, you can have stuff like, like this, left side and right side, and you don't, and then on the context, like relationship and stuff like relationship, for example, that is unbound, but then in the context object, you define a field called relationship, and then suddenly it exists there, okay? So these function contexts are given automatically to function calls and include at least the object on the keyword this, right? Supposed to be a this in there. So basically, if you have something like apple.getInfo, what's going on underneath is that this getInfo function is going to get a context object that has this bound to the apple object. Okay, so that's how this variable is resolved, because it's inside this context object. All right, so that was one mysterious part of JavaScript. Where does the this come from? Another mysterious part is something called prototypes. And to make things even more irritating, it's not the word prototype in here. It's not exactly the same as it was used back when JavaScript was designed. That when people use the word prototype, they used to refer to, creating objects directly, like JavaScript is doing, like little object literals. That's supposed to be a prototype. But for some reason, in JavaScript, the word prototype means something slightly different. It's almost the same, but it's slightly different, which are these hidden objects associated with every visible object. So basically, for every visible object that you have in your program, there's a hidden object that's associated with it. That's called its prototype. Okay, so that's you need to know. There's a shadow. There's always a shadow for every object in JavaScript. That's called the prototype. And these prototypes hold additional information about the objects. The rules of method dispatch or variable lookup are such that if something is not found in the object, then the next place where the virtual machine is going to look at is in the prototype object, this shadow object that's associated with every object. So it's also a mechanism for code reuse, as I will show. So let's go back here to this, when you define an object like this, like via a function. So you have a function, and then you have, if you have a function like this, when you say new apple, you're basically copying the function. You're copying the function entirely, and you're creating an apple 1, and then you're copying the apple again, and then you're copying it, and you have an apple 2, and you have two separate copies of the same kind of template, right? The same kind of function object. So including not just the values of the fields, but also the method. So basically, this method getInfo gets duplicated, right? It's literally duplicated. So something even. So how do you not duplicate? Okay, so one way of not duplicating, so code reuse, is to associate this function not with the apple itself, but with the prototype of apple. And again, as I told you, every object in JavaScript has a shadow object, so that is accessed with .prototype, including the functions, because as I said, functions are objects. Okay, so there are prototypes associated with every object, and so you can say, okay, so not in the apple I'm just putting the fields, but then on the prototype of the apple, I'm putting an extra key value pair that's a getInfo, which is this function, okay? And now this is in the prototype, not in the main function. And so now when I create an apple, okay, and then I create it again, I get only one. The prototype is the same. So the prototype for all these copies is the same. So pictorial is something like this. So the first version, when you have the method directly defined in the apple function, the apple function as the prototype, and then when you say new and you say new again, you basically duplicate. So including, you get replicas of the first function, okay? And each one is pointing to the same, they happen to share the prototype, but there was nothing in the prototype, okay? So when you do the second version, when you put the prototype, the function in the prototype itself, right? So first you said you define the type and the color, and that's the function apple. And then you say that the prototype of apple gets an extra field, so the get info. So you're doing this, you're putting the get info here in the prototype. So when you say new apple, you create a copy of apple, which now has only these two fields, right? And they all share the same prototype. So they all get to share the get method info, the get info method, okay? So this is trying to list a little bit about how you make sort of classes in JavaScript by using this prototype object that is associated with every object that you see in your program. So how do you do inheritance with prototypes? So here's a typical example of mammals and cats and dogs and stuff like that. So here's a function mammal that's supposed to be the superclass, right? When you want to do sort of object-oriented programming with JavaScript, emulating classes and stuff like that, then what you define on these templates is just the fields, the base types, the things that are to be duplicated whenever you create a new instance, right? Each instance gets their own. And the things that are to be shared among all the objects of that particular class, they are put in the prototype. So for example, here, you put the field in here, and then you put a method, have a baby, in the prototype, and another one to string in the prototype. And then you can do more things. You can do crazy things. Like for example, you can have a cat. Where am I associating a cat? I don't have cat, but I can say cat.prototype. I can actually make prototype be other functions that I defined. Okay, so I can have my own functions and then say that the prototype of my function is that other object that I defined elsewhere, which is what's happening here. I'm saying that the prototype of this other function is this one instance of this mammal function. So here's the function cat. Here's the prototype, another function that I put in the prototype, and then I say some animal and some new cat. But if I say my pet, which is a cat, have a baby, then that have a baby method is not defined on cat. So my pet is a cat, right? My pet is a cat. And the cat does not have a method called have a baby, right? However, so the way that it works, it's looked up in the function, it's not there. So when it's not there, then it follows the prototype link. And the prototype link is pointing to a mammal object. And so have a baby is found on the prototype of that object. And so that method is available and is found, okay? Basically, objects can be created with a secret link to another object, and if an attempt is to access a name in the visible object fails, then that name is looked up in the invisible object. Right. So the secret link is not used when storing. Right. You cannot. The new members are only added to the primary object. So stuff like that. So if you have, you create an object. And you give it my old object. This is essentially a prototype link, right? So you say, this is my object over here, and this object has a field that's the hidden field that is basically pointing to some object that you already have, okay? And so things that are not, if you say my new object.name, it will be found. Even though it's not here on the new object directly, it follows the prototype link and it's found there, right? And then if you say, but if you want to change it, or if you want to set it, then you immediately duplicate it. That's a tricky thing. So you can read the things that are shared, but once you want to update them, then you automatically make copies of that thing in the base object. It's super tricky. These kinds of semantics are very, very tricky. So if you want to find out more about classless objects, you can follow those links. More about function prototypes, which are interesting kind of hybrids between Self and Python and Ruby, but applies to the word function, which we kind of have an idea that the function is supposed to be just a function like a lambda function or whatever. It turns out that in JavaScript, functions are implemented as objects. They have a bunch of methods that some of them are documented, right? For example, the method call, the method apply. Then there's the prototype is always there because it's part of an object. So the functions are objects in JavaScript. That's what you have to remember. And there are things available in there. So that's why JavaScript sometimes feels a little weird, because you're dealing with a function and suddenly you're calling the dot notation on the function itself. It doesn't make very much sense until you just realize that functions are objects in JavaScript. And then everything starts to make a little bit more sense. So, okay, in JavaScript, classes are functions. Functions are objects, and they're all key value maps anyway. Once you realize this about JavaScript, things start to make sense. Okay, it's very hard to understand JavaScript coming into it without realizing what is going on. But this is what's going on. And at the bottom, everything is a key value map. All right, there's just dictionaries all the way down, and some of these dictionaries are called functions, and they're actually also objects. They have fields and methods that you can call, and you can emulate classes with functions, which are objects. Okay, so it's a fun language to learn a little bit, not necessarily to code up. This slide deck has more slides, but you can consult them. They have a bunch of more details about JavaScript, but I am not going to talk about them. All right, so what I want to do next is two things. So let me go back to the exercises for this week. So again, you're doing the exercise 13, which is this model of objects that you have in Self, you have in JavaScript. So it's a world where the objects are just maps, very similar to JavaScript. And here's again another look now that you that I talked about JavaScript a little bit. Now you can understand what you are doing in the context of a modern language that is super popular, and that this model of objects is, prime time in JavaScript. All right, very different from the model of objects of Java and C++. All right, so and remember, there's an extra credit for those of you who want to do this. How do you bring the this into these methods, these methods over here? Okay, so the other thing that I want to talk about today is frameworks and object-oriented frameworks, and those became as popular and as and even more useful than object-oriented programming itself. There were the frameworks for programming, GUIs, and entire application frameworks. And so I'm going to talk about some of those, and they kind of bloomed in the world of object-oriented programming first. Now you have frameworks in all sorts of different languages, but they really bloomed in object-oriented programming, and now there's a reason why that happened. So I'm going to talk about inversion of control, and I'm going to talk about PubSub, as it is known. The full name is Publish Subscribe. Let me talk about the inversion of control first. So inversion of control is an interesting thing that happens both in typed and untyped languages, and statically typed languages have a little bit more twist to them. But let me talk about the inversion of control. So usually, when your code calls the library function, so typically, you code up your code, and typically you call some function somewhere on libraries that somebody else wrote, right? So when the normal way, the direct way of interaction between your code and the library code is that your code calls the library code, right? So there's a function somewhere in here, library, and your code calls the function, and you get a return value of some sort, and that's how it goes. In version of control situations, you get the opposite, okay? You have your code, and now you have some library, and now the library calls your code. Okay, this is what inversion of control is. Now, how is this possible? How can we make it so that some library that we didn't write, that library doesn't know anything about our code, right, at all? How can that library call our code? And moreover, why would the library want to do that? Like, why is this useful to do? Lots of questions. I'm just presenting you the mechanics of the technique of inversion of control. But besides the mechanics, there's the reason of why. Why would you want to do that? So yes, let me talk about why you want to do that. So you want to do that on because here's when you want to do it. You want to do it when you are writing some sort of software that you know almost everything about the context of the application, right? You know almost everything, but there are some things that you don't know, right? There's some customizations that you just don't know. And it depends on who's going to customize that software. So there's some code that somebody still needs to write to make the application complete. Okay, so you can write a generic code that does almost everything, but then the bindings maybe to, I don't know, to the database or maybe to the UI or something like that. There's some extra little code that you cannot do right in a generic manner. It has to be very concrete for the specific end use of your software. Okay, so in that case, how do you do it? Well, you write everything that you can write. And then when there are those holes, let's call them this way, that you don't know, you make a call into the unknown, right? So your code calls the unknown, calls some function or some object or something, calls something that you know that when you write your software, it's still not there, right? But you also know, you assume that when your software is packaged with somebody else's little end code, that those functions will exist. Functions or objects, that code will exist, right? So you call it by, and I will tell how, but it doesn't exist when you actually write it, but it will exist by when somebody else packages their own code with your code, okay? So how is this done? It can be done, so the enablers of inversion of control are, of course, higher order functions. Okay, so basically you code up a function in your framework that receives a function as an argument. Basically, the end user, which is a programmer, your end programmer, the third-party programmer, sends you a function, which is the customization function, the actual, concrete function, and then you just call that function because you coded up your framework, assuming that there would be a function there with that argument name. But another way of doing this inversion of control, and that was very much popularized, is with objects, right? And objects, basically you write up a function or a method or whatever that takes as an argument an object of a certain superclass or a certain interface, right? Of a certain type that you know that the type exists somewhere. You don't know exactly what the implementation is going to be, but somebody else is going to provide that implementation and it's going to call your function. That function is going to be, called with some object that actually exists somewhere else. So, and in statically typed languages, this can be done with abstract data types. So in dynamically typed languages, inversion of control is relatively non-problematic because you can write a piece of code that calls a function that is not yet defined, right? You can do that in Python, in Ruby, in all the interpreted languages. You can write a piece of code that calls some function with a name, and that function, at the time that you write it, it doesn't exist yet. And it's only when you go and run it, if the context of the execution has that function defined, then your function will work, because it will find the function that you don't originally had. Okay? So in dynamically typed languages, inversion of control is relatively non-problematic. You just have to make sure that when the code runs, and if you call a function called foo, that the context of the execution has a foo function defined somewhere by somebody, right? However, in statically typed languages, things are a little bit more problematic, because the compiler checks that everything that you call actually exists, right? So you cannot just, if you have a function call for a function that it's not defined anywhere, you get the compile error and the code does not compile. So how do you ensure that how can you call something that you don't know, right? Well, you can use either inheritance, and then your users are going to subclass your superclass, or you can define an interface, which is, that's the whole purpose of interfaces. You as the framework writer define an interface, and then the users of the framework define classes that implement your interface, right? And at the point of the execution, the compiler is happy because it's type safe. The types exist, the methods of that type exist. It just doesn't have an implementation. At some point when it runs, that implementation needs to exist, but it can be provided by the users of your framework. So basically something like this. So here's the functional version of a callback, of a version of control. So here's your methods. Your code is on the left, library functions are on the right. So here's your function. Here's your main. Your main calls the library function and gives it a higher order function, my function. Basically, it sends your function as a parameter, and then the library function simply calls that function. Okay? This is the way of doing inversion of control in functional languages. In object-oriented languages, it's a little bit more contrived, but it's sort of the same. So you have the framework defines some interface, okay, IA, and now this you are supposed to implement IA in some way. Okay? So here's your class A that implements IA, and then somewhere in your code you create a new A, which is an instance of your class A that implements the interface IA, and then you call that some library function, sending it your object that you created, which is we know it's an instance of your class A, but for purposes of the framework, it just knows that it's it has the interface IA. It doesn't care about how it is implemented, which exact class it is. So when the framework writer writes the framework, this is all they need to write. They don't care about implementations, and they just call that method on that particular on whatever class is object is being sent in here. Okay, and callbacks and type safe callbacks. So what is the framework? So I've been using the word framework, I haven't really defined it. So there's a little difference between the framework and the library. So a library is just a set of utilities that you can have access. So there's the standard libraries of all languages, there's third-party libraries. There's basically code that your code calls, right? It's a direct control. So your code calls the library. Frameworks are the other way around. Frameworks are the ones that basically just do almost everything. Okay, they just leave you to do the details. Okay, so typically frameworks are the ones that contain the main function. They contain the main function. Basically, you just write little hooks that the framework is expecting. So things that are frameworks, for example, Django framework, Spring framework. I'm sure you guys can think of other frameworks that you've come across. So these are big pieces of software, okay? Big pieces of software that do a lot. In fact, they do sort of a family of applications. They do a very strong type of application. And then it's up to your code just to send the customizations to the framework. It's just your code, for example, for Django, which is a web programming framework. Django does everything with respect to, the network, implementing HTTP, all of that stuff. It's all already there. Basically, it's a framework for developing web applications. And your code, all your code needs to do is to code up, the handlers, the request handlers. Define what are the routes and what's the handler for each route, right? And so all of the applications out there that use Django, they are all looking the same. They all look the same. It's just the handlers that are specific for each application, right? But Django is this big, gigantic, iceberg. It's the bottom of the iceberg. That's the framework. And then your code is just the tip of the iceberg, right? So it's a difference between the library and the framework. So a framework allows developers to build complete components, applications with small customizations on deployment sites. That's the value of frameworks and the value of inversion of control. Okay, that's how if you are developing a framework, then you have the power to then call somebody else's code, and you don't know what that code is, but you have the power to just call it by means of specifying what the interface to that code should be, right? So it's a very powerful technique, inversion of control. All right, so having explained in general what's the difference between frameworks and libraries, let me go and explain two types of object-oriented frameworks that are sort of very popular, just like styles of organizing things. One is event-driven and the other one is publish, subscribe, and there's a lot more, but these are sort of two classes of frameworks that you see a lot of them out there. So event-driven is when first you register, so you have some object B and you have some object A, and the B says, hey, call me back when something happens, when something that I'm interested, call me back. Okay, so first there's a registration, right? The B registers with A for a specific type of thing, event. And then sometime later, that event happens. And so A calls all of the handlers that have registered for that event. So then there is a callback at some time later, okay? So event-driven frameworks were popularized by GUIs because GUI is, naturally asynchronous. Like, you need to define what code you want to run when there's a mouse movement or mouse click or a keyboard type or something like that. And all those GUI events are naturally asynchronous. And so it's a good way to express this sort of event-driven framework for GUI, saying, here's what you should, let me register my handler with you framework. When the user clicks the mouse, here's what you should call on me. Right, so this was popularized by OOP. It's typically object-oriented, but not necessary. So you can do this also in functional programming, as I said. So the callbacks are just the functions instead of objects, like in object-oriented programming. I will explain all of that. So the publish-subscribe model are slightly different. And the way that this works is that typically in these frameworks, there's two categories of components. Okay, so there's the published components, which are components that publish events, and there's the subscriber components, which are the ones that subscribe to events. And publishers and subscribers can, every component can be a publisher and a subscriber of different events, right? But basically, the idea is that if you are publishing some event, there's a common bus, some sort of a middleware, okay, that takes care of all these event management. And you say, okay, something happened, I'm going to publish that this happened, and whoever is interested should have previously registered with this middleware. And then the middleware is responsible for distributing the event to everyone who has subscribed to that type of event. So this is a very, so basically that's producers and consumers, and the power of this architecture or this framework style is that it completely decouples producers from consumers. It completely decouples components binding, okay? So in normal way of composing functions or components, or whatever you call it, is that you have a function and you call another function by name, right? So or an object or whatever, you call it by name or by type. So you need to know what are the names of those things. It's a very strong requirement that you need to know what the names of those things are, either the name of the function or the name of the type. Even if you don't know the name of the class, you need to know the name of the type. And that is very high bar. Okay, so what I'm talking about here for PubSub, these PubSub architectures, they don't even need to know anything. You don't even need to know who these components are. All you need to know is that there are these events. You just need to know what type of events are there, right, in the system. And it's basically a data-driven architecture. You just know that there are, for example, a news event or a account credited event, okay? Money was deposited. So those events, that's all you need to know. And once you know what types of events there are, it doesn't matter, you can hook up new components into the system anytime. They don't directly communicate with each other. They communicate indirectly via producing and consuming different events that happen. It's super powerful architecture, very extensible. So having presented that, let me show you how this looks like in my exercises. Let me go here and go to the Hollywood style, which is the callbacks. So these are the callbacks, and let me just go through the code a little bit. So what I have here, I have in both of these cases, my code is divided into two parts. It's the framework part, which could be a separate, separate component, but it's not, it's all in the same file. But there's a part that's supposed to be the generic framework. And then there's another part of my code that is supposed to be the concrete customizations of the framework, okay? This is true in both cases. So in the case of the event-driven framework, I have the framework itself defined here as a class, and it's super generic, okay? And the story of this framework could be many, okay? Could have done different stories for this framework. The story of this framework is the following. The applications of this framework have three types of events. There's the load event, there's the work event, and there's the end. Okay, there's basically three. It supports applications with three phases. Okay, an initial phase of loading stuff, an initial phase where stuff is happening, it's actually processing, and then there's an end that terminates the application. Okay, so that's my story of my framework. And so this framework has literally just three lists of event handlers. There's the load event handlers, the do work event handlers, and the end event handlers. And what it does, it provides registration methods for each one. And so applications can register for load, can register for do work, and can register for end. And the method is, so the main method of my framework, so the running my framework means that first I call the load event handlers, all the load event handlers. Then I call the do work event handlers, and then I call the end event handlers. That's it. That's my story, my generic story of my framework. Okay, any application that can fit this model can use my framework. So let's see how we do this for term frequency. So now there's the entities of the application. So here's the data storage class, the stop word filter class, the word frequency counter class, etc. Okay, and here is how I instantiate them. So I first create the framework, and then I create all of them, give them the framework as the first arguments, and eventually other objects too. So for example, the data storage object knows about the stop word filter, and the word frequency counter knows about the data storage. Okay? And they all know about the framework. So let me look into one of them. For example, data storage, in the constructor, it stores the stop word filter that it gets as an argument, and then it registers for the load event, because this guy needs to have a load phase to load things from the disk, and then it registers for do work, right? That's all. It registers for load and it registers for do work. And for load, it registers this handler over here, the load method, and for produce word, it registers this one over here. Okay. And furthermore, so they're all using this framework over here, the underlying framework, but in between themselves, I've coded it up so that some of these objects also provide event handlers to others. Okay. So for example, the data storage class also offers a register for word event method that other objects can register to. Okay. All right. And so when this guy is producing words, then one of the things that it does is to call these handlers that are waiting for words. Right? There's a lot of calling back going on in here. All right. And so the same thing over here for a stop word filter. This one registers for just the load event. What does it do? Yeah, it has a little method is stop words that others can call. And the word frequency counter registers for a word event on the data storage object, and it registers for an event on the framework itself. Hold on, I need to go shut down my dog that is doing a lot of noise. Just a second. Sorry, even on the recording, these things happen. Okay, so this is the event-based, event-driven framework. Okay, so what I'm asking you is to do a, see exactly what I'm asking you. I'm doing, right, so either this one or the other one. And so let me show you the other one before I even talk about the point to exercise in either one of them. So this is the event-driven framework. The PubSub is slightly different. Again, as I said, there is a part of the code that is the framework. So here's the event manager, right? That's the PubSub middleware. That's my middleware. And then there's the applications, okay? So the middleware in this case has to manage subscriptions. That's what it has to do. So it has a dictionary of event types to event handlers. So, and basically it provides two things to the rest of the applications of the component. It provides a subscribe method and it provides a publish method, right? Subscribe expects that you give it the type of event and the handler, and the publish, it just says, it expects you to tell you what event you are publishing, all right? So, and in either case, when somebody is subscribing to a type of event, then you either add the event, a new event that didn't exist in the subscription dictionary, or you just add the handler to that particular type that already existed, okay? So this subscription dictionary is a map from event type to a list of event handlers, okay? I think this is seen here, okay? And here's when it happens, when it's a new type of event. All right, and publish, what publish does is that for every, so you get the event over here, and you look into the subscriptions, and if the event type is in the subscriptions, then you call every single handler for that event. That's what the event manager does. And now these classes, the application classes, are completely independent of each other and don't know about each other. They don't have references to each other at all, unlike the previous example. So for example, let me just show you here. They all know, so down here in the main, I create the framework, and then I create each one of these objects, and each one only knows about the framework. They don't know about each other. That's sort of the characteristic of publish subscribe architectures, is that the components don't know about each other. They just know about the middleware. And then to run, I say run. And so here's what, for example, data storage manager in the constructor, it subscribes to the load event, and it subscribes to the start event. And this is what the load does. And this is what the start does, produce words, right? And for example, look at the produce words. So when it's producing words, it's publishing every single word as an individual event. So each word is an event, all right? And whoever of the components is listening for word events or waiting for word events is going to get that word event. But the data storage manager doesn't care. It doesn't know who is waiting for word events. It's completely unbound to any other component of the system, okay? And so, for example, the stop word filter is subscribing to the load event, and it's one of the subscribers of the word event, right? And when a word occurs, then it goes here and it checks if it's a stop word or not. And if it's not a stop word, then it publishes an event called valid word. And now whoever is waiting for valid word is going to get this event. Okay, etc. So this is how PubSub works. That one of the main differences between this one and the previous one, the event-driven architecture, is that in the event-driven architecture, you still have, it's still allowed to have references between the objects, okay, of the application. The objects of the application can still know about each other, right? But in PubSub, that is not the case. In PubSub, the components of the application don't know directly about each other at all. The only way that they interact is through these events. They subscribe to events, they publish the events, and so that's the only thing that is going on is through the events. They don't know about each other directly, okay? So now about the point 2 in each one of them. So the point 2 part of the exercise is that you extend your code with another functionality that is words with Z, okay? So you are supposed to print out the 25 most frequently occurring words, and then you also print out how many words have the letter Z, okay? And you are supposed to do that in a very sort of uncommitted way, okay? So you're supposed to kind of do it after you have written your applications, okay? So how do you expand your code in the minimum possible way with minimal intrusion in your code so that you have this extra functionality, okay? And so think about it. In the PubSub, it's basically, and also in the event-driven framework, you just need to think that now you're going to add something else additional to what's already there. So you're not supposed to change the classes, right? You're not supposed to change the classes that are already there. You're supposed to add some other class, some other component that does this additional thing. And this component is supposed to subscribe to certain events, right? Or register for certain events, depending on which model you do. But it's independent of the classes that are already there. That's the main thing. You cannot change the classes that are already there.